Ever since the very first PC, and up until around 2004, Intel increased the performance of its CPU by increasing the speed of the only core the CPU had. And as you all know, we then moved on to multiple cores instead. This transition happened during the Pentium 4 era, making the Intel Pentium 4 3.8 GHz the fastest single-core CPU ever made. So when building a Pentium 4 retro rig, it's kind of the obvious choice, at least for me. Only problem is, these are now very rare and expensive collectibles, fetching silly money on eBay. But there is a way to get around this, because Intel also made a 3.8 GHz Xeon, identical in core, sharing the same instruction sets, but with unlocked features like SMP and ECC support. In today's video we're going to have some fun with an old IBM from 2006 and turn it into a super fast Pentium 4 era retro rig. I bought this server on eBay for basically pocket change a few years ago. Since then we have repaired the motherboard and done a bunch of upgrades. I'll put a link in the description if you want to watch the repair video too. We actually did 2 upgrades to this IBM in the repair video too. We installed one of those 3.8 GHz CPUs, and despite it not being on the supported options list, it totally worked. We then installed the second CPU and the optional VRM. And finally we upgraded from 512 megs to 4 gigs of PC2 3200 RAM. We have already run benchmarks before all the upgrades, so we will have something to compare with when we're done with the speed demon. And we can move on with a bunch of upgrades. Okay, let's start with the power supply. I checked inside a few months ago, and if I remember correctly, all the power rails are connected together inside, meaning we could get enough power for the graphics card just by using any of the Molex cables, together with a cheap adapter like this from eBay. However, the recommended specs for the graphics card we're going to use is 650 and ideally 850. And this power supply can only do 408 watts. So we're going to replace it. A standard power supply is slightly lower and the width is the same. And we've got plenty of space inside the machine to install a much longer power supply. However, the screw holes don't quite line up with the original screws. I tried to find an adapter plate, but unfortunately I couldn't find any. Well, I considered making my own plates, but 2 of the screw holes actually line up. This may be hard to see on camera, but there is actually a large ridge here inside the chassis that the power supply is resting on. There's not much to gain from a proper adapter, so I'm just going to use it like this. And this is, by the way, a Corsair HX 850 watt power supply, so plenty of power for whatever upgrades we want to do. The 2 power connectors on this motherboard are standard, so no issues here. And this motherboard, by the way, is made by MSI. It's an MS9151 version 1. Okay, before we do the first test, I'm going to upgrade the CD-ROM drive to a DVD drive. Partially because I want to get rid of this ID cable and get some better airflow in the machine. Being an IBM, it's super easy to swap drives in this machine. All we need to do is to push on this blue sticker and pull the drive out. Actually, I decided to install it in the second bay instead. And then I'm going to install the I/O panel for the sound card in the first bay, mostly because of the looks. I'm not sure I will ever use it, but it just looks right in this machine. So I guess that ID cable just went right back into the machine right away. Okay, the next thing to go in is some more RAM, because we still have 2 empty slots here. But I went through my stash and I found these guys. They're actually faster than the RAM we have installed here, and much larger. So in the repair video we installed 4 of these 1 gig modules. They are PC2 3200R. They were listed as an available option from IBM, but obviously not with an HP logo. And these guys are 4 gigs PC2 6400p. So I guess I'll remove these 4 and install 2 of these. And that should give us double the memory. Okay, let's turn the machine on and see if they are compatible. Okay, it's counting up the RAM. So we've got 5, 6, 7, and 8 gigs, and the post moves on. So I think they are compatible with this board. But I don't know if they take advantage of the higher speed. I guess we could check later, and if they're not, we can add even more by using these sticks too. Okay, so next we need some super fast storage. This machine only has one PCI Express slot, and we're going to need it for the graphics card, obviously. Then it also has 2 regular PCI slots, and then it also has these weird and wonderful PCI X slots. So there wasn't much to choose from, but I finally managed to find this controller here. It's an LSI SAS 3041X-R. It's obviously a SAS controller, but it can also take SATA drives. I was planning to install it in the repair video, but despite the eBay ad saying the cables were included, they were not. And this card has some super weird cables. It is a proper SAS controller, but for some weird reason, this card here has regular SATA connectors instead of the typical SAS connectors. But after having spent some time on eBay, I finally managed to find these weird cables. It's a cable with a regular SATA connector in one end that connects to the card, and then it has a SAS connector that connects to the drive. Super weird cable, but once I found them, they were actually pretty cheap on AliExpress. We're gonna go completely bananas with storage, because we are going to connect these guys to the controller. And these are IBM branded 200 gig SAS SSDs, and we're going to connect them in RAID 0. So a bit wasteful perhaps, but I got them for cheap, so why not? We might as well use them and get the fastest possible storage in this IBM. But first I'd like to thank my favorite sponsor, PCBWay. Aside from making excellent PCBs, as we have seen in many of my videos, they also do CNC machining, 3D printing and PCB assembly. Perfect for prototyping and vintage computer restorations like this one. If you need some help designing your next PCB, check out their new PCB design surveys. Get an instant quote now for your next project at PCBWay.com. Thank you PCBWay for supporting this channel. This machine was designed to take 6 of these hot swappable SCSI drives, and we used one of these to test the machine in a repair video. So we need to somehow fit these much smaller SAS SSDs in the original drive cradles. So I went on AliExpress and picked up a bunch of these. So let's try them out and see if they will do the job. And yes, I think they do. There's even a cutout at the back here, so the cable will fit. And these cables also require separate power. This power supply is semi-modular, so it has the power cables for the motherboard and 2 PCI Express cables for the graphics card. And then we can just add whatever we need. Since this IBM was designed to use SCSI drives, we need to get rid of this backplane to get all the cables to come through here. Being a service-friendly IBM, it has a tab with a blue sticker underneath here. So if we push on it, we can flip the entire drive bay out. And all we need to do here is to remove a bunch of screws. Now we can just remove the entire backplane, getting plenty of space to get the cables out at the back of the drives. Okay, all 4 drives connected to the controller, and it ended up surprisingly neat actually. I thought we would get a big mess of cables here, but we didn't. This is looking pretty good, and power is connected too. Okay, so next I'll connect the DVD drive and the diskette drive, and then we'll test those drives and the controller. Okay, let's turn the machine on and see if this works. And I think I forgot to mention, so this board has 1 dual channel IDE, 2 SATA ports, 1 floppy connector, and 2 SCSI connectors. So a very flexible board. And here's our LSI boot BIOS. So I'm gonna type Ctrl+C to enter the settings. Okay, so here's our controller. Let's see if we can figure this out. Let's try RAID properties. Okay, so I'm not familiar with LSI controllers. It's a bit different from other controllers I've used. But I think we should create an S volume. Okay, and here are our drives. Well, I guess this is where we pick the drives we're going to use. Okay, so it's complaining that we have data on all the drives. And it prompts me to use a special configuration tool. Okay, so where is that tool? Well, I guess we could just ignore that error and see what happens. So I'm gonna type C to create. Create and save new array. So I'm gonna pick save changes, then exit this menu. Okay, so are we done here? I think we are, but I'm not quite sure. So let's hit escape and escape again. You sure you want to exit? Well, I can't pick save here, but we have saved already. Yeah, as I mentioned, I have never used LSI's RAID utility before. So let's try exit to configuration utility and reboot. Okay, initializing the LSI controller. So let's skip this. Searching for devices. Okay, now we only have one drive. That is 740 gigs. So I think we're okay. Next up we have the graphics card. And for this build we're gonna go with the GTX Titan X. And the reason for picking this card is because it was the last and the fastest graphics card from NVIDIA to have proper VGA. And I'm going to use this IBM with the proper CRT. Now there are converters, so you could use pretty much any CRT with pretty much any graphics card. I've never tried those adapters myself, but I'm sure they are good enough. But since I had a spare GTX Titan, we might as well use it. And it should be more than sufficient for any games I want to play on this machine. But before we use it, we need to clean it and replace the thermal pads, because they are very old and probably very dry. And if I remember correctly, it's put together with a silly amount of screws. By the way, I just did a partial edit, and twice in this video there was a strange buzzing noise in the background. And unfortunately I have no idea what it was. I had to look through my equipment here, but I can't figure out what it is. So let's just hope it won't come back. Okay, sure enough. I'm not gonna count them, but there was something like 20 screws, which seems kind of weird for a graphics card. And many different types, so now I just need to remember which screw goes where. But first we need to replace the thermal pads here, because these chips get very toasty. And I want to make sure they are kept nice and cool by the cooler. And then I'll of course replace the thermal paste here. It's a bit dusty inside, but actually not too bad. I've definitely seen worse. But I'll clean the dust out before I reassemble the card. I went through my stuff here and I found these. The packaging is two different colors, but I think these are the same. I hope they are, because if I remember correctly, one of these isn't quite enough for one card. Okay, it's a bit tricky to get everything on camera here. But I cleaned the PCB with an anti-static brush. And then I cleaned all the chips and the GPU with some IPA. And then I cleaned all the aluminium parts here with the Hoover. So everything is nice and clean. And one of these packs was enough. So if you're fixing one of these cards, 4 strips is more than sufficient. So I'll reassemble the card and we'll try it out in the machine. I forgot to mention, I did of course reapply the thermal paste on the GPU. Also this card was missing the standoffs. But I found some spare, so we're all good. Okay, card looks pristine now. Well, aside from my fingerprints, I'll clean them off later. And it should be nice and cool now, with some fresh thermal pads and fresh thermal paste on the GPU. Let's connect it to the machine and test it. By the way, this VGA card doesn't have a proper VGA connector, but it does have a DVI connector. And since the card has proper VGA, that's what these pins are for. If it does, you can use a cheap adapter like this to connect your CRT display. Here's an example of a DVI connector without VGA. This card obviously has VGA on this connector here, but as you can see it's missing the 4 extra pins here. Okay, power connected. Here goes. Okay, we've got an image. Awesome. Tend to buy quite a lot of graphics cards untested to keep the cost down, but this seems to be a working one. Awesome. Okay, and here's our logical volume. Well, retro gaming is no fun without sound. So the next card to go in is a 64 meg SP0460 Sound Blaster XFI Fatality. And this is of course the matching card for that front panel. Unfortunately it connects to that front panel with a large IDE cable, but I'll see if I can route it reasonably well so it doesn't mess up the airflow in the machine. This cable looks a bit funny, but if I'm not mistaken I think you can use a regular IDE cable if you're missing the original cable. But I think there are some exceptions, so you need to do some reading online. Well, one of the two PCI slots is underneath the graphics card here, and it's quite hard to reach the other one, so we don't quite have enough room for the sound card here. And I don't want to move the controller because this PCI X slot is much faster than these two. But we can install PCI cards in PCI X slots, so we can install it down here. Okay, I actually managed to get a pretty decent cable management here. So this machine has one large fan here that cools the cards, and then it has two fans back here. So the airflow is coming through the front panel and then through the drive base, cooling the two VRMs, and then the CPUs, and then it's sucked out through the back here. So this should work quite well, I think. Okay, before we install an OS on this machine, there's one more thing we need to fix. When we installed an OS on this machine the previous time, there were two drivers missing, and I think they are included on this disk. But Windows wasn't able to find them. And this disk contains tons of files, so I wasn't able to figure out which one it was. And Windows couldn't find them, probably because they are compressed. So what we need to do is to run this disk first, and then install an OS. Okay, let's boot the machine with a disk in the drive. And here I'm going to pick CD-ROM drive, of course. Although it is a DVD drive. Okay, and it boots. I've never tried this DVD before, but I'm sure we'll figure it out. Okay, and it's starting IBM Server Guide. IBM Server Guide, set up an installation. And we better accept all this stuff. Welcome to Server Guide. Server Guide reduces the complexity and providing device drivers. Awesome, this is looking good. So let's hit next. Okay, so this might be a problem here, because we are prompted to pick an OS, and I'm not going to go with any of these. Oh, actually we have other networking operating systems here. Let's try that first. Okay, next we are asked for time and date, so that has been fixed. Oh, I see. This is actually a skippable step. Okay, so maybe it's possible to run this disk after the installation too. I wasn't aware of this option here. Okay, let's move on. Okay, and then we're getting a server configuration summary. So it's an X Series 226, machine type 8488 with 8 gigs of RAM, 2 CPUs, and BIOS version 1.75. Thanks to one of my viewers, we were able to update the BIOS to the latest version, because IBM had removed them from their servers. Okay, click Exit to shut down your server and begin your OS installation. Okay, and we're gonna go with Windows 7 64-bit Ultimate Edition, because this seems to be the last 64-bit version this server supports. We have tried with Windows 10 and Windows 11, but I couldn't make it work. And I actually don't have a working Windows 7 machine at the moment, so I did some thinking and I think this is going to be perfect for me. So let's boot to the Windows 7 installation disk. And I'm obviously not going to use this machine as a server. This is purely for retro gaming. Windows is loading. And about the RAID 0, by the way, it's normally not recommended to use it, because it's pretty risky. But this machine is just a toy. I'm just going to load up a couple of retro games. I'm never going to place any important files on this machine. And RAID 0 is going to give us a little bit more speed. Okay, so I'll skip ahead here, unless something interesting happens. I'm sure you have seen a Windows 7 installation before. Well, something interesting actually did happen during the installation. So I tried to activate Windows by phone, as I've been doing with my retro stuff for many years now. Apparently that service has been shut down. So instead I was referred to a new web page. And the process was pretty much the same. I had to type in a gazillion of numbers, and then I got a gazillion numbers back that I had to type into the machine. So it totally worked. It had just moved online, so we're all good to go and can move on. Okay, so the first thing we want to do with this machine is to go to legacyupdate.net. It's a community-run resource to update old versions of Windows. I've never tried this before, so let's see how this works. Install legacy updates. Let's try this. Okay, apparently this DVD is a pretty early version, so I'm gonna have to install Service Pack 1 first. That was a silly mistake. I could have grabbed a much later DVD. Well, I'm not going to reinstall the machine, so I'm just gonna install all the service packs required. Okay, and this totally works. Awesome project, love it. But this is going to take a while, so I'll skip ahead here. Well, as you can imagine, that took a while. So don't make the same mistake. Check and make sure you have the latest version of Windows 7 if you're installing it on your retro rig. Okay, so next, let's check that RAM. So I'm going to run CPU-Z version 1.79. And if we go to the memory tab here, we can see that the DRAM frequency is 200 MHz. Okay, so those PC 6400 RAM sticks are underclocked and only running at PC 3200 speeds. Well, that's too bad. But in that case, I'll install these RAM sticks too. And that is going to give us 12 gigs of RAM. Okay, said and done. And this machine now has 12 gigs of RAM, which should be more than sufficient for any games I want to play on this machine. Unfortunately, the mystery remains with the two drivers here. I was hoping they would be installed with that IBM CD-ROM we ran earlier, but unfortunately not. So this is going to remain a mystery, but I'll keep digging and see if I can figure out what it is. I also installed some proper drivers for the GeForce card, and I went with version 472.12. And as for the sound card, I installed Sound Blaster XFI Series Support Pack 8, modified by Daniel K. I'm obviously not going to do any banking or any important stuff online with this machine, but I will occasionally go online. So I also installed Supermium. It's a Chromium-based web browser, compatible with Windows all the way back to Windows XP. So this is a must-have on a retro gaming rig. Okay, time for benchmarks. I'm gonna go with 3D Mark 03. Before we did all the upgrades, we got an embarrassing score of just 18 points, which is absolutely ridiculous and completely unusable for retro gaming. The reason I went with 3D Mark 03 instead of the somewhat more period correct 3D Mark 06 is that this IBM wouldn't even run 3D Mark 06. It was that slow. But this is running pretty smoothly. While I was waiting for Windows updates, I did some more research. And these CPUs are not just extremely similar, they are actually made from the same silicon wafer. So they are actually the same thing, just in different packaging. And apparently, Intel used microcode masking and fuses to cripple the Pentium 4 version. Also, the dies destined for the Xeons went through more rigorous tests to ensure they could handle the heat of continuous heavy 24/7 server workloads, while the Pentium 4 dies were validated strictly for standard desktop environments. So the fastest single-core Pentium 4 is exactly the same thing we're running on this machine now, just slightly crippled. Well, we're definitely going to beat 18, that is for sure, but question is by how much? So we are expecting some really good Pentium 4 scores here, but probably slightly faster since we have extremely fast storage. I'll skip ahead here a bit in edit because these benchmarks are quite long. These scores are, by the way, not FPS. This is an overall score of how fast the system is. Holy cow, 50,497 points. How's that for an improvement from 18? Holy crap. This must be some kind of record on the channel. I don't think we have seen such a massive improvement in any other projects. Well, I'm gonna call this build a success and start recording the next video. Before you leave, like, subscribe, leave a comment, and consider joining me on Patreon. And now is a good time to watch the repair video of this IBM. Link on the screen here and in the description below. And I'll see you guys again next week.